Welcome to homework.
Okay, we've got two examples of dimethyl sulfoxide. Two drawings of dimethyl sulfoxide, let's say. And the question is, first, what is the relationship between these drawings of dimethyl sulfoxide? These are resonance structures of dimethyl sulfoxide. Okay, that's just vocabulary. Anytime you've got the same molecule, but all you've done is shift electrons. For example, this bond became a lone pair, and then the charges shift as a result. Not always, sometimes everything remains neutral. The important thing is that when you shift those lone pairs and or bonds, those are called resonance structures. Okay, next. Is DMSO polar? Yes, right? And we can get evidence of this from, for example, this resonance structure, which shows a formal negative charge and a formal positive charge, right? But also consider that even in its neutral form, the oxygen is more electronegative than sulfur, right? It's higher on the periodic table and they're in the same group. Therefore, we know that oxygen must be more electronegative. And if it's more electronegative, then that means it's drawing more electron density to itself than sulfur is, which would put a partial negative charge on oxygen and a partial positive charge on sulfur. Therefore, DMSO is polar. It has a net. Right, and that particular polar bond isn't canceled out by another polar bond. For example, like carbon dioxide. Yes, it has carbon and oxygen, and those are polar, and this one pulls this way, and this one pulls that way, and in the end, it cancels out to nothing. It's non-polar. That's not the case with DMSO. Okay, let's continue. Finally, C, using formal charges, select the most important resonance structure for DMSO. Well, we know that when we draw something or pick the structure that is preferred, we want to minimize formal charges if possible. That's kind of our goal, right? When it comes to drawing Lewis structures, we want to minimize formal charge. And if we look at B, there's a formal negative charge on oxygen and a formal charge, positive charge on sulfur, whereas in A, we have neither. Right, so A definitely has less formal charge, and A is the preferred resonance structure for DMSO.